Next on my tiny bench is this Magnavox CBD471. Beautiful vintage compact disc player. Simple, kind of sleek layout. And the complaint is that it doesn't read a disc. So let's give it a shot. Power's on. Mechanism works. Doesn't read first attempt. Doesn't read second attempt. We'll take a look. Back shortly. Back on my tiny bench with the Magnavox CBD471. I think most people know by now the Magnavox were made by Philips, and this particular one was made in the Belgium plant. I think it's in 1987. It uses a TDA 1541 DAC chip, 1541, not the 1541A. Still a good chip, and nice copper plating on the PCB board. It uses a little different configuration here for the transport compared to some of the others that use the CDM4 laser mechanism. What I'm gonna try, I think I'll clean the laser first with a dry Q-tip and just try it again. Let's just make sure it's not dirt. Inside is pretty clean, but who knows? It's always a good first step. We'll clean that, try it again. Then if it's still not reading, it's just, let's be honest, that's quite a good possibility that will be the case. Then what I'll do is I'll remove this transport. If it's like the others, you pull these 3 screws, tilt this down, then there are some screws here, and then this comes out backwards. And then you flip it over, there's a board, a servo board, right on the bottom of the CDM mechanism. And then we'll see. There's one particular capacitor that's notoriously bad, but this doesn't look like it uses the standard Philips axials. Obviously these are axials, but they're not I was going to say the blue ones, but those are blue. The ones that typically go bad, that I find bad frequently, are these. Come on, focus. So if you're working on one of these units and you see any of these caps on the servo board, good idea to check them, because save yourself a lot of grief if you swap them out before they go bad. They develop really high ESR, and apparently they leak as well. So that's a pretty common fault with these units. More in a bit. Back on my tiny bench with this Magnavox CBD471. Here's the mechanism. It is a standard CDM2 without any of the hyphens or dashes, and adjustable right there. Generally though, usually I find these don't drift out of adjustment. If they're not playing, it's usually something's gone awry. If you see down here, here's one of those Philips axial electrolytics that I was talking about. And let's see what she reads on the magic beeper machine. See, I think this one's 4725, so 4725. We're looking for, 40 microfarads, and we're looking for ESR to be about 1. I know it's not always accurate reading in circuit, and it looks like the capacitors drifted down to about 12 microfarads instead of 47, and ESR is up to 15.5. So I think the first thing I'm going to do is just replace that. and see what that does. Probably replace it and just clean things up, put it back together, see if that fixes the problem. I know reading things in circuit isn't the best way to get an accurate reading, but when we're talking about capacitance, if there was anything that was affecting it in parallel with it, it would most likely cause the reading to go up. Capacitors in parallel increase. And ESR, if there was any resistance in parallel with it, that would cause the ESR to go down because resistors in parallel decrease. But this is showing 15.5 ESR, so even if that's not the problem, it is something that needs to be replaced. So I'm going to go ahead and take care of that now and be back shortly. So here we have the board completely out of the unit. And as you can see, this is the capacitor that we're going to be swapping out. Look on the foil side. Looks like there's been some work done. Looks like that chip might have been replaced at some point. And let's see, right there. Looks like there might have been some work done there. So you can see what that is. Transistor. Otherwise, it doesn't look too bad. And the capacitor that's going in is a little bigger physically, but I don't think that's going to present a problem. And this is a 50 volt, just because I happen to have it in stock. And so if it's a 50 volt at 47, let's just see what we get. Capacitance is 43, and see the ESR is 0.35. So I think we'd be looking for 0.5, 0.6 or less. So that's a good capacitor. I'll put it in, put the unit back together, and then see how she does. I may check a couple of these other capacitors while I've got it apart, but the ones that are notorious are those right there. Surprisingly, I know there's a lot of attention on electrolytics, power supply electrolytics these days, but usually these are just rock solid. You know, if you're in here doing it, certainly feel free to replace them if that's your preference. I'm of the mind, though, that if it's working, I'm not going to torture the board any more than I need to. That's my current thought anyway. I know there's some disagreement on that. Be back shortly. We're back on my tiny bench with the Magnavox CBD471. Recall that we had found a bad capacitor, one of the Phillips axial capacitors in the servo circuit, and replaced it. After replacing that, the unit still didn't want to work. So we did some additional troubleshooting. Basically, I pulled the board out and I checked the ESR and values on all of the capacitors, mostly from the backside in circuit, using the trusty Peak ESR 70 Plus. I also have a capacitor wizard which I like to use, but for this project this was handy, so I went with it. I found two way out of spec capacitors in the focus drive. Let's see if I can eliminate the glare on this. It's this 220 mic and this 220 mic, and they are both located under the transport. I replaced them both with some really nice Elna Silmix that I had on hand. Probably overkill for this application, but I had them and they were handy, and they read really nice on the capacitor checker. Ones that were in place, these are supposed to be 220 mics. One read about 130 and one read about 400, and ESR was a little higher. I don't quite remember, like 6 or 7 ohms, something really high. So I had to swap those out. After I swapped them out, though, I still had some additional problems. And I found myself in the motor circuit. This motor works a little different than a fairly typical or lower cost unit. This uses what's called Hall sensors rather than what's referred to in the industry as a toy motor. And let me see if I can find a schematic for you. There we go. Oh, I'm upside down. What's new? Basically what I found within this circuit, and just so that we're clear, we've got a signal coming in here from the servo. We've got plus and minus 9 volts, and then this is tied to ground. The servo circuit goes to these two motor coils, which concern the direction that the motor actually spins. What I found as I got in here was there's an LM324, which is a quad op amp. It was bad, so I replaced it. And since I had it apart, I went ahead and swapped out these transistors for brand new ones. And these are BC33740 and BC32740, both of which are still apparently available. I had some on stock, or in stock, so I swapped those and swapped those. And basically there's a Hall IC here, which is a sensor. It's not really an IC, and it concerns the magnetic movement of the motor, and it senses movement, and magnetically it sends a signal to the op amp, and the op amp then tells the motor turn, 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 turn. So it should be symmetrical. It's not quite symmetrical. I may show an image of that momentarily. Well, it's working, and I'm a little nervous about tinkering with it, to be honest with you. I need to be candid. Even after I had these swapped out, I still had some problems with the unit not wanting to start up. It was kind of jerky and hesitant. It would go doot, doot, doot. So down in here, you'll see 2 potentiometers, variable resistors. This one controls focus, and this one controls laser current. In the service manual, they imagine that you've got some extender cables that allow you to pull this up and out, and then you can probe around under here. What I've actually done was I've kind of pulled this out, clipped on to some equivalent areas, electronically equivalent, and I set the focus for mid. I set the laser current for a little bit more than mid, and I finally got the table to turn in the right direction. Then once I got it to turn, I set these values on a test disk for something close to what they recommended. What you'll see here, bear with me, sorry about that. This is the laser current, and it should be 50 millivolts plus or minus 5. This is the focus offset, which should be 400 millivolts plus or minus 40. And we start her up with this test disc. See, it spins very smoothly. Let me just disconnect that. And you can see we're within plus or minus 5, that's 47. That one's a little high, but I found that it varies quite considerably from track to track and from disc to disc. So I picked a disc that I'm pretty happy with. I set it for spec 400, and then it seems to work flawlessly throughout, so I'm going with that. And I'm quite happy with the operation. You can hear it's quite silent. I'd mentioned before that Hall effect I see in the motor circuitry, it's not quite symmetrical. Let's see if I can show that without causing too much craziness. So, if you remember the circuit, it was there were 2 motor coils. This represents what's being sent to one motor coil. This represents what's being sent to another motor coil. I may try and tweak that to make them a little more symmetrical, because you see that one is a bit higher than the other, but it's just working so nice. As I said earlier, I'm a little reluctant to change it up too much. Next test, we will do the gap test, and by gap, I use a test disc that intentionally has gaps placed in it, and the farther it can play, the larger gap, it shows just how capable the drive is, the CD is, of interpolating that gap. So I'll be back momentarily and we'll run through that next. Okay, we are back with the Magnavox CBD471. And as I mentioned, I'm going to be running the test to determine how big of a gap the CD player can play through without interruption. The disc I use for this, and I know I've mentioned this before in previous videos, it's called Digital Test Compact. It's by the French producer Pierre Vergne. I do not have any idea how to say that, but let's go with that. Highly recommend it. So we'll give her a shot, and we'll start on 27. Any reasonable CD player should be able to play 27. Plays it fine. 28. What you're listening for is just no cracks or popples or skips. 29. I usually like to give it about 6 seconds just to make sure it's establishing the track. 30. $31. 32. 33. 's excellent. 34. Up. there it was. So we played 33, but not 34. As soon as you start to hear it mistracking, stop it. You don't want to cause any further damage. You don't want to knock off your servos or anything like that. So just not worth continuing to play. So we got to 33, but not 34. Check the handy reference book. That tells us 33 means it can interpolate a 1.5 millimeter gap. And as you see here, standard is 27. So 0.2. Average CD player, competent CD player in the Red Book standard is 0.2 millimeter gap. This 1.5 millimeter gap, what is that? 7.5 times wider? And just to show what I'm speaking of there, look at a smooth operation. There are actual physical gaps. I'm not sure if I'm getting too much glare. Right there. Those gaps. That's what it's trying to read over. So, pretty nice. And I'm thinking more and more that I'm just not going to worry about that lack of symmetry on the Hall motors. Because, I mean, it operates smoothly, boots up pretty quickly, stops on a dime. Just doesn't seem like it's worth the risk. So I think I'm going to package this up, disconnect all of the crazy test configuration I've got going on here, put the top back on it, and find a willing buyer who would love to enjoy this vintage Magnavox CBD471 using the CDM2 and the TDA 1541. Nice transport, really nice DAC chip. And I think that's it this week, today on My Tiny Bench. Thanks for tuning in.